So in the last video we have discussed about the interfacing of the input output devices, having basic interfacing concepts along with the how the device is being selected and how the data is being transferred. And then we have also discussed about the what will be the logic circuit for the LED output port, as well as we have also discussed absolute and the partial decoding. Now today we are going to discuss about, in this video we are going to discuss about the interfacing of the input and the output devices. Of course there are various circuits which can be used to decode as well as to interface any input and output device with the microprocessor. However, all the techniques, whatever is being used, there are basic 3 steps which has to be followed for detection of the device and actual data transfer to take place. Now the first step is to decode the address bus to generate the unique pulse corresponding to the device address. Second one is that to combine, whenever I say combine, it means it is going to have an AND operation, and gate will be used for AND gate is used for what? AND gate is used to device address pulse as well as the control signal to generate the device select pulse. And the third step is to use the input output select pulse to activate the device port. Now this particular figure which is in front of you, that is address decode using 3 to 8 decoder. This demonstrates a circuit in which 3 to 8 decoder as well as 4 input NAND gate is used to decode the address bus. Now the decoder has 8 output lines, thus we can use any one of these lines to generate the device address for a particular device. So it means 8 devices can be connected with the output of the 3 to 8 decoder, and this circuit used to generate the address pulses for the 8 different addresses. Now this is the first step which I have discussed. Second step is to combine this decoded address, whatever address is being decoded from the 3 to 8 decoder, we have to combine this decoded address with the appropriate control signal to generate the input output select pulse. Now if it is an input device, we have to input device, so it means it will be reading process. If it is an output device, it means it is a writing process. So for input device, the control signal which will be generated will be IOR, that is input output read signal, and for the output device we have to generate input output write signal, that is IOW signal, to generate the pulse, select pulse. Now in this particular figure, O0 of the decoder is logically ANDed with the negative AND gate along with the IOW control signal. Now the output of that gate which is connected with where the input is O0 and input is IOW, the output of that gate will be generating an input output select pulse for the output port. Now similarly in the above figure you can see that there is a NAND gate also. There is a NAND gate in which the O2 of the 3 to 8 decoder is connected in the form of input along with the IOR, which is again generating input output select pulse, that is IOSCL. So both the gates are generating select pulse. Of course the first one is selecting, the below one is selecting the select pulse for the output device, and the previous one, the above one, is generating for the input device. Now the third step is to use these pulses. Now these pulses which are being generated in the form of a input output select pulse, these pulses will be used to enable the input port as well as the output port. Now as far as this figure is concerned, this problem is concerned, the input output select pulse which is going to enable the LED, that is the below one, the LED with the output port address, what will be the output port address of that? That will depend upon the value which we have to give in the form of A0 to A7, and depending upon the value O0. So, depending upon the value from A0 to A7, the output of O0 will be going to define the address of the port in which the LED is connected. Similarly, the condition of A0 to A7 along with the O2 output of the 328 decoder which is connected with the input device. So, this is the circuit by which it is going to generate the addresses of the individual devices. Now, it is written F8. Why it is F8 is the address for the output LED device? Because we have to have A3 to A7 all should be equal to 1 if we want to enable the 328 decoder and find out the O0. And A0, A1 and A2 should be 0, 0. It means A7, A6, A5, A4, A3, A2, A1 and A0 will have the value 1, 1, 1, 1, 1, 0, 0, 0, whose output will be equal to F8. Similarly, the 328 decoder O2 output is connected with the tri-state buffer. So, it means the address of this particular device in which the switches are connected, that will be depend on the value from A0 to A7. Now, the output is O2. So, output is O2, it means the value will be different from the value from O0. O0 means A0, A1 and A2 is 0, 0, 0, and O2 means the value is equal to 0, 1, 1. So, depending upon that, the address of that port is F8. So, FA is connected with IOR to generate an input output select signal for the switches, and F8 is connected with the IOW to generate or enable the latch for the LED device. So, this is about the explanation of this. Now, there are certain important concepts related with the this interfacing of the input output devices. The first important concept is when an input output instruction is executed, 8085 places the device address on the demultiplex, either the lower order bus as well as to the higher order bus. Now, either the higher order or the demultiplex lower order address bus can be decoded to generate the pulse corresponding to the device address on the bus. The third one is the device address pulse is ANDed with the appropriate control signal, whether it is a read signal or it is a write signal, and when both the signals are asserted, then only the input and the output port is being selected. And the fourth one is any interfacing device, whether it is a latch or it is a buffer. A latch is used with the output port and the tri-state buffer will be used for the input port. Now, the address bus can be decoded either by using NAND gate circuit, or it can be used with the help of a decoder circuit, and it can be either absolute or the linear select decoding techniques, whatever techniques we are going to adopt. The linear select technique is also called the absolute technique. Now, this reduces the component cost. Partial decoding is going to reduce the component cost, but there is a problem with that. The addresses, there will be different addresses which can be multiple addresses for the individual devices. Now, I am going to now demonstrate that how the output display can be interfaced if the output display is governed by 7 segment LED display. So, how we can, what will be the program and how we will design the circuit for that. So, before we are going to discuss about the interfacing output display, let us first discuss what is the 7 segment LED display. Now, a 7 segment LED display consists of 7 segments and 1 decimal point, 7 light emitting diode segments and 1 decimal point. It is very clear in this particular figure. Now, the necessary segments are glowed by sending an appropriate signal for the current flow through these diodes to display the number. Now, if we want to display 1, if we want to display 2, whether we want to display 3, it all depends that what LED has to be glowed. Now for example, let us say we want to display 6. So 6 means all the LED will be displayed besides the B. So 7 segment LED are categorized into 2 groups. Now there are 2 kinds of LED. One is common anode and another one is the common cathode. And these common and the 7, all these 7 segments A to G, all these 7 segments are connected to the data lines from D0 to D6 respectively, and the decimal point is connected to the data line, that is D7, if the data point is to be used. Now as far as the binary code required to display a digit, if we want to display a digit, so we have to write a binary code for that, and this binary code is determined by the type of 7 segment display, which kind of 7 segment display we are using, if we are, whether we are using common anode or whether using common cathode, as well as what is the connection of the data lines. Of course, I am saying that from A to G it is connected from D0, D1, D2, D3, D5. It also depends upon the connection of the data lines as well as the logic required to light the segment, which segment we want to light and which segment want to off. Now if we want to display a digit 7 on this LED, then, and if it is a common anode, if it is a common anode 7 segment LED and we want to display digit 7, so logic 0 is required to turn on a segment if it is a common anode. अगर हम कॉमन एनोड LED यूज़ कर रहे हैं तो जिस भी सेगमेंट को हमको लाइट जलाना होगा, we have to turn it on, we have to provide a 0 to that, meaning thereby if A is connected to D0 and if we want to light on A segment, it means D0 bit should be equal to 0. That is the meaning. So if we want to display 7, so if we want to display 7, it means A, segment B and segment C should be on and the rest of the segment should be 0. It should be very clear. A, B and C should be on, meaning thereby A, B, C it will be connected to D0, D1 and D2. So it means these 3 bits should be 0 and the rest of the bit should be equal to 1. So what will be the bit pattern of that? The bit pattern of that will be equal to 78, because if we have suppose D0 is connected with A, so D0 is 0, D1 is 0 and D2 is 0 and the rest of the bits are 1. So it means it is equal to 78. So it means 0, 0, 0, 1, 1, 1, 1, as well as the bit 7, chunki bit 7 is connected to DP. So bit 7 is not taken into the account because we don't want to display the decimal point. So it will be in no care condition. So it will be 0. So the value will be 0, 1, 1, 1 and 1, 0, 0. So that is equal to 78. Now the code for each digit is determined by examining the connection of the data lines of to the segment as well as the logic requirement. Therefore, to design an output port with the certain address, suppose the address is F5, the address is F5, whatever we have seen here, the address here it is F8. Now suppose we have the address F5 is, we have designed a circuit so that we have a F5. So we have to design an output port with the certain as address, that is F5. The address lines should have the following logic, that is A7, A6, A5, A4, A3, A2, A1, A0 should have values such that it will be displaying F5. Now if we want to have F5, so what we will do, the F5 address can be achieved by using A2, A1 and A0 as the input line to the decoder, and A3 can be connected to active low enable signal E1. Now the circuit is shown here. We have connected O5 for the selection of the latch, and this is going to generate F5 because A0, A1 and A2 value should be, A2 should be 1, A1 should be 0 and A0 should be 1. So this can be obtained with the help of the output O5. So what we are trying to do, A3 can be connected, A0, A1, A2 की position मालूम चल गई, A3 can be connected to the active low enable, that is E1, and remaining address line should be connected to the E2 through the 4 input NAND gate. Now this figure shows that an output port with an address F5. This is showing the output port with the address F5 because A5 is 0, A3 is 0, A4, A5, A4, A5, A6 and A7 is 1. So that is going to generate a address that is F5. Now the output O5 of the decoder is now logically ANDed with the control signal IOW, and this IOW is again output of a NAND gate whose input is input output memory as well as the write signal. So it is generating an input output write signal. So the O5 and the input output write signal is the input to this AND gate, and it is going to generate the input output select pulse, and that will be used to enable the 74 LS373 latch. Now the control signal IOW is generated. I have told you that IOW is generated with the help of IO input output memory as well as the write signal. So in this way, this will be a circuit, interfacing circuit, which will be interfacing a 7 segment display LED with a address F5. If we have to generate another address, if suppose the address of this output port is F8, then we have to change the addressing lines of the, we have to make certain adjustment in A0, A1, A2, as well as we have to select out of the 8 output any one of the output, so that we are able to generate the address for that. So if it is so that the address of the port is F5 and we have to make we have to display a digit 7, then what will be the program? So the program will be, first of all, what we will do, the program in which what we are going to do, we will try to put 78 into A. And what is the 78? 78 is the code by which we are able to get the digit 7 to be glowed, and then we have to display this this value of accumulator, which is 78, which is equivalent to display the 7 digit 7. We are going to transfer this accumulator value into the port whose address is defined as F5, which is actually a 7 segment LED display, and then we are going to halt. So in this way, this interfacing circuit of the LED can be done. Thank you.